everybody. I wanted to run through the practice exam that I gave you over the weekend just to make sure that you felt prepared for this physics exam on Monday. So we want to calculate the total mechanical energy of this object, given that we have a potential energy here. We're also told that when we pass through 0.5, this is the velocity that we have, and all forces are conservative. So the total mechanical energy is just the potential plus the kinetic. I can write that as u of x plus 1/2 mv squared. And let's just go ahead and plug in our numbers. So here's the thing. If I get the total mechanical energy, when we say it's conserved, that means wherever I get the number, that's the total energy all the time. It may trade that energy between potential and kinetic, but the total is going to be whatever I calculate. So in this case, it's going to be 8.0. X to the fourth is where I actually know where the speed is. So I'll put 0.5 squared plus 1/2 times the mass, which is 2, times v squared, which is 2, and we'll square that. And so I'll end up getting, let me just make sure I have this right, 0.5 to the fourth times 8. I think it's going to give me half a joule, yeah. So this is to the fourth, sorry. It's going to give me 1/2 joule, plus here I've got an additional 4 joules of kinetic energy. So I'm getting 4.5 joules of energy total. Now we want to know the x-coordinate where the object has 0 kinetic energy. So let's be clear. We have 4.5, and that's the total energy. And we want to know, so we have 8.0 x to the fourth, and we want to know where we have 0 kinetic energy. So what we're saying is the total energy equals the potential plus the kinetic, and we're saying 0 kinetic energy means that all the energy is stored as potential energy. So we got 4.5 over 8.0, and we want the fourth root of that. So and we're going to take that to the 1/4 power. And so we're getting about 0.87 plus or minus meters. That's where that's happening. Now we want to know the momentum of the object at x equals 6. Once again, first let's use the total energy, and we'll use that to get the speed. So we're going to say 4.5 equals 8.0 times 0.6 to the fourth plus 1/2 times 2 times v squared. And so we can do a little bit of simplification. We're going to end up getting that 4.5 minus 8 times 0.6 to the fourth. All of that under a square root should be my speed. I can go ahead and simplify that, and I'll get a speed of 1.9 meters per second. And then we want to know the acceleration of the object as it passes through x equals 0.6. So here we know that F equals ma, and the force is going to be the negative derivative of the potential energy. So let's just go ahead and calculate that out. So that's going to be 8.0 times 4 times x cubed. So that'll be negative 32.0 x cubed. We'll need to put in 0.6 here. And so let's just get the force. So that'll be negative 32 times 0.6 cubed. So that's given me negative 6.9 newtons of force. And then let's get the acceleration as negative 6.9 divided by the mass, which is 2. And that's going to give me negative 3.95 meters per second squared. Awesome. So that's problem number 1. I'll do problem number 2 in the next video.